So now I want to talk about the kind of last step of a convolutional neural network, which is pooling. So we talked about before convolutions and padding. And essentially, what those do is just that you apply a filter to an image, you get a different representation of it that shows more meaning, but you don't want to lose all of your pixels, right? And so you still want to preserve elements of that original image, and so you sometimes add layers of padding to preserve pixels. But like I kind of talked about at the very, very start, you have kind of things like GPUs and TPUs. And those are really, really good for memory-intensive operations. So again, we have this, wonderful blue image here. We'll just say that these are the pixels of it, of a picture of a rose, whatever it is. And so we have, we're going to go with a 2x2 kernel. As you can see, the box is moving across a 2x2 kernel. There's no padding because you can see that most of the pixels have reasonable values. One thing to know about padding, though, is just that you could repeat the pixels you have outside. So, for example, we could add another layer of 7352 on the top, or another layer of 2695 over here, or 7840, whatever it is. But you can add zeros over here, or you can just repeat pixels, or whatever it is. But essentially, here there's no padding. That's really all we need to see. And you have a 2x2 kernel that's moving across the image. What's happening is just that you're applying a max pool. What does that mean? So pool is essentially, I have a picture here of a pyramid count that we're working with. And so this right here is your ML model, and this over here is kind of the data that you have. And so you're going to feed the very bottom of it right into your ML model, and it's an inverted pyramid. And the idea of just that you have all this image data starting off, but then what you're going to do with pooling is just that you try to minimize it as much as you can, but so you're still trying to preserve the important parts of it. So you have this image that has applied a bunch of convolution filters. You have contours or a specific version of the image that you're looking at, and here are the pixels. But essentially you want to minimize it because you might not have a lot of memory or a lot of processing power that can handle such a big image, and you do what's called max pool, which means that you take this subsection and you take the highest pixel value. So an 8 here, what's going to be 6 here, 9 for this part right here, and 9. And so you're going off 4 quadrants, and you can see, they align really well. And so what pooling does is just that it takes a really, really big image that has the convolution filters, and then it's going to turn that into something that's smaller, but still has the same basic filters. And so you can have different types of pooling layers. You can have min pool, which is basically the same as max, but instead of taking the max, you're going to be taking the min. So that would be 3, 1, 0, 3 here. But you can also do what's called average pooling. I'm not going to calculate each of the values. Let me just erase this real quick so it's a little clearer. But essentially for average pooling, you would take each quadrant, you would add up these values, and then you would get the average. Let me see if I can find one that isn't too gross. So this one here adds up to be 25, and then 25 divided by, zoomed in. Sorry about that. 25 divided by 4. Why does it keep? Sorry. 25 divided by 4, I'm just going to go ahead and say it. That's just going to be 6.25. And so like over here, this layer would just be 6.25, and this would be another average layer, etc. And so pooling, there's different types of pooling you can do, and you would end up just basically getting a small output. And so I'm just going to go over quickly the 3 kind of, filters or parts of a convolution neural network that we talked about. First one is convolution, which is basically the filter. Second one is padding, which you can use to increase your filter size or to increase the result of the filter. And then the last one is pooling, which basically just effectively minimizes your convolution or filtered result. So that's basically all you need to know. And in the next class, I'm just going to do one more quick review.